Good morning students, welcome to Royal Palace College online classes. So till last class we were discussing about the CET part or CET or Neet of the electrochemistry. Now today onwards I will start with the new concept, that is solutions CET. Okay, so firstly we have completed solid state, then recently electrochemistry. Now let us start with another chapter of physical chemistry, that is solutions. Okay. First of all, what is I will try to do some revision of this chapter in 1 or 2 classes. Then we will go into the solving problems part. Okay. So first of all, what is solution? Basically, solution is represented as solute plus solvent is equal to solution. Solute plus solvent is equal to solution. Now what is solute and what is solvent? Okay. So if I mix any two compounds, if I mix any two substances, let them be solids, let them be liquids or gases, or maybe solid and a gas, or gas and liquid, or solid and liquid. It can be anything. If I mix any two compounds, then the resultant mixture is called solution. In that solution, we say the components as solute and solvent. Then what is solute and what is solvent? Basically, the component that is present in minor proportion, the component that is present in minor proportion is called solute, and the component that is present in major proportion is called solvent. Is called solvent. For example, let us assume that I have mixed some alloy. I made some alloy. Alloy means mixture of metals. Let's assume I made an alloy with gold and copper. With the gold and copper. Assume that the sample, first alloy, sample 1. First alloy, sample 1 contains 20:80 ratio of gold and copper. Second sample contains 80:20 of gold and copper. So 2 alloys, 2 samples I got. Now this is an example of the solid in solid type of solution that we will see in the classification. But let us assume there is 2 samples of alloys. Both are gold and copper only. Sample 1 contains 20:80% of gold and copper. Sample 2 contains 80:20% of gold and copper. Now in this solution, okay, which is sample 1, in sample 1 which is solute, and in sample 2 which is solute. Okay, sample 1 gold is solute because it is present in less percentage. Copper is solvent. Similarly, sample 2 gold is solvent, copper is solute. So like that you need to assume. So whatever the component is present in minor quantity, it is solute, and whatever the component it is present in major quantity, it is solvent. Okay, and it is not compulsory that always a solution should contain only one solute or only one solvent. Okay, basically any solution that is consisting of only one solute and one solvent is said to be binary solution. Okay, means only 2 component solution. Only one solute, only one solvent. Binary solution. If there are more tetra and so on. Okay, means what I mean is, let us take one beaker of this one beaker, a glass beaker. Assume I have some water in this. Initially I mixed some NaCl or table salt in the NaCl. Then it becomes a sodium chloride solution. Assume that after that I have mixed one more salt, that is potassium chloride in this KCl. Now that means here it will become three component system. Two solutes, one solvent. Okay, so it is not always necessary that only one solute should be there and one solvent should be there. You can mix, you can have a mixture of solutes and mixture of solvents also. There is no issue in that. So this is what is basically solute and solvent is giving rise to solution. Then when any two components are mixed, here in solutions we are mostly considered with binary solutions only. So if any two components are mixed together, then it is a binary solution. And to know the percentage of the components present in any solution, we have some concentration terms. Okay, some different concentration terms are there. In that, first one is mass percentage. Mass percentage. Mass percentage is also called weight by weight percent or m by m percent. Mass percent. Now what is mass percent means, if you consider both the solute and solvent in grams, okay, or in kgs or in milligrams, both should be considered in weight only, by weight only, then it is mass percentage. And it is given by the formula weight of the solute or mass of the solute, by mass of or the weight of the solvent into 100. Similarly, we have another. And what does mass percentage means? For example, if I say 20% glucose solution by weight, means 20 grams of glucose is dissolved in 80 grams of water. 80 grams of water. That is the meaning of 20% glucose solution by mass or by weight. Similarly, next percentage is volume percentage. Volume percentage is given V by V. Means both should be considered in mLs or liters. So volume of solute by volume of solvent into 100. Now 10% example, 10% ethanol solution, 10% strength ethanol solution, if they say, it means that 10 ml of ethyl alcohol, 10 ml of ethyl alcohol is dissolved or is present in 90 ml of water. 90 ml of water. Another quantity we have mass by volume percent. Mass by volume percent. Now what is mass by volume percent means? It is the weight of the solute present in 100 ml of the solvent. Okay, weight in 100 ml of the solvent. For example, you can say generally it is used for pharmaceutical purpose. Pharmaceutical purpose they will use M by V percentage. Mass of the compound dissolved in 100 ml of the component. Means for example, they say for example 2% iodine solution. 2% iodine solution or iodine tincture of iodine, whatever they call. Of course it is a different percent. I am here giving 2% mass by volume iodine. What does that mean? 2 grams of iodine is present in 100 ml of the solvent. Okay? 2 grams of iodine present in 100 ml of the solvent. That is about mass by volume percentage. Then we have another term called as ppm. ppm means parts per million. Parts per million. And it is given by the formula number of parts of solute. Number of parts of solute by total number of parts by total number of parts of solution into 10 power 6 into 10 power 6. Basically ppm is used for any solute if it is present in very minute quantity. Okay, any pollutant if it is present in nanograms, micrograms, okay, picograms, like that if you take. Okay, meaning very little percentage. Okay, very less percentage if they are present, then we use ppm as the unit to measure. Okay, so next is mole fraction. Next unit is mole fraction. It is indicated with this zeta. Okay, it looks like X. What is mole fraction? Number of moles of component by total number of moles. Okay, total number of moles is called as mole fraction. See, if it is a two component system, let us assume there is two component system A and B, then mole fraction of A is given as number of moles of A by number of moles of A plus number of moles of B. Okay, this is for mole fraction of component A. If there is another component B, let us assume, then mole fraction of B is given by the formula number of moles of B by total number of moles, that is number of moles of A plus number of moles of B. And remember, for any solution, if there are n number of components, then mole fraction of ith component, I number of components, is given by the formula ni by summation n. Summation means number of ith component moles by total number of moles. Summation means total. Okay, and you should always remember that mole fraction of sum of the components, mole fraction of all the components is always equal to 1. It is unity. Mole fraction of sum of the components in the solution is always equal to 1, unity. Okay, and next term we need to define here is molarity. molarity. As you know, molarity is defined as number of moles by present per liter. Number of moles per liter. So this again you know there are different formulas. Number of moles can into 1000 by volume ml also you can write volume ml, or you know that formula weight by molecular weight. What is it? Weight by molecular weight, number of moles. Weight by molecular weight into 1000 by volume in ml. Volume in ml. Okay. Similarly, we have another term called molarity. Molarity. Molarity is indicated with letter capital M. Capital M. Molarity is indicated with letter small m. Small m. There is no big difference between these two. Only the units differ. This is number of moles of the solvent present per liter. Here, number of moles of the solvent present per kg. Sorry, number of moles of solute present per kg of solvent. That is the only difference. Here we take volume in liter, there we take weight in kgs. Weight of the solvent. Similarly, this can also be written as n into 1000 by weight in grams. Or you can also write it as weight of the solute by molecular weight of the solute into 1000 by W in grams. There is no issue. And one more important point you need to remember that molarity is temperature dependent, whereas molarity is independent of temperature. Means molarity value can change with the change in temperature. Molarity value does not change with the change in the temperature. Why? Because molarity depends upon volume of the solution, whereas molarity depends upon weight of the solution. Volume can change with temperature, whereas mass does not change with temperature. So that's why molarity is temperature dependent. Molarity is temperature independent quantities. Okay. Now next. Next concept is types of solutions based on physical state of solute and solvent. Solute and solvent. So, solute can be gas, solvent can also be gas, solute can be liquid, solvent can be gas, solute can be solid, solvent can be gas. Similarly, solute can be gas, solvent can be liquid, solute can be liquid, solvent also liquid, solute can be solid, solvent can be liquid. Similarly, solute can be gas, solvent can be solid. Solute can be liquid, solvent can be solid. Solute can be solid, solvent can also be solid. Based on the physical state, we can classify the solutions like this: gas in gas type, liquid in gas, solid in gas, gas in liquid, liquid in liquid, solid in liquid, gas in solid, liquid in solid, solid in solid. These are the types based on physical state. Let us see what is this. Gas in gas type of solution. Basically, all those solutions in which solvent is gas. Basically, all those solutions in which solvent is gas are called aerosols. Because gas, air is the solvent in them. Okay? All those liquids, all those solutions in which liquid is the solvent, basically they are commonly called solutions. Okay? If the liquid is water, then they are called aqueous solutions. Okay? Similarly, all the solutions in which solid is solvent, then such type of solutions are called solid salts. Solid salts. Let us see some basic examples. Gas in gas. Gas in gas means you can take simply example of air. What does air contains? Air is mixture of nitrogen, oxygen, carbon dioxide, sulfur dioxide, etc. So what is there in the mixture of gases? So gas in gas, example air, oxygen, nitrogen mixing together. Okay. Similarly, liquid in gas. Liquid in gas means the basic example you take moisture, humidity. Water vapors are present in the atmospheric air. Air is a gas. Water vapor is liquid. So liquid in gas. Okay. Similarly, solid in gas. Solid in the gas means any dust particles, like for example charcoal. You are burning something. You are burning some wood or any tire and all. Black smoke appears, which dissolves in the air, right? So that black smoke is nothing but carbon particles, which are getting dispersed in the air. So that is solid particles in the gas, smoke. Similarly, gas in the liquid. Example, cool drinks. You take any cool drink, okay, any beverages. What is there? Carbon dioxide will be pumped into that sugar syrup solutions, right? So it is gas in the liquid. Liquid in the liquid, mixture of liquids. Okay, for example, water mixed with ethyl alcohol or benzene phenol mixture, like that. Okay, solid in liquid. Solid in liquid means example glucose solution you take or salt solution you take. Salt plus water, glucose plus water. Solid in liquid. Gas in solid. Gas in solid means, example you take hydrogenation reaction. We take hydrogen gas always in hydrogenation with platinum, palladium, nickel. Why do you take? Because these particular metals, platinum, palladium, nickel, they have high tendency to absorb hydrogen gas. So it is gas in solid type of solutions. Similarly, liquid in solid. Liquid in solid means you take for example amalgams. Amalgam is what? Alloys in which one element is mercury. So mercury is liquid metal that is present in solid form of either zinc, copper or any other metals you can take. So amalgam, alloy. Solid in solid, all alloys except amalgams, all the alloys, brass, bronze, different type of alloys. Solid and solid mixture. Okay, so this is the basic classification. Okay, you will find in solutions. Then coming to the next Solubility. The term solubility. Solubility means it is the maximum amount of the substance that can be dissolved in a given solvent at a particular temperature. Means let us assume we have taken a beaker of water and we dissolve sugar in it, sugar or salt. If I add 1 gram sugar to 1 liter of water, it will get dissolved. Similarly, 2 grams, 3 grams, 20 grams. What happens? See, in the minor proportions, in the initial stage, the total sugar likely dissolves in the complete water. But as it reaches some saturation or as it reaches certain point, then the sugar particles will not dissolve completely. They start settling down at the bottom of the beaker. So, based on the solubility, solutions can be classified in 2 types. Unsaturated solutions and saturated solutions. Saturated solutions. Now, what is unsaturated solution means? The solutions in which additional amount of solute can be dissolved. Means let us assume 1 beaker of water has tendency or capacity to dissolve only 20 grams of sugar. So I have made 1 beaker of water with 10 grams of sugar, dissolving 10 grams of sugar. Then I made 1 solution. After certain time, I will add 1 more spoon of sugar to the same beaker. Will it dissolve? Yes, until it reaches its maximum point. Okay, so that type of solutions are called unsaturated solutions. The solutions in which additional amount or extra amount of solute can be dissolved at a given temperature is called unsaturated solution. Similarly, what are saturated solutions? Saturated solutions means the solutions in which additional amount or extra amount of solute cannot be dissolved. Means let us assume maximum 20 grams of sugar can be dissolved in a beaker of water. Now I prepared 20 grams of sugar solution and I kept there. After some time I will add 1 more 5 grams to that extra. Will it dissolve? No. So such kind of solutions are called saturated solutions. Means maximum solubility has been reached. After that no more solute can be dissolved in that particular given solution. So based on that we have classified 2 types, unsaturated solutions and saturated solutions. Okay, and apart from this types of this one solutions, then we have another next topics, that is factors affecting the solubility of solids in liquids. Similarly, gases in liquids also. Okay. Then we come across the Henry's laws, Raoult's laws and all that I will like to revise in the next class. Thank you for